In this clip I will focus on coordinates of vectors with respect to ordered bases like b is v1 to vn. So the first property is that for all x in Rn, if we scale up the vector t, then it's basically, with respect to the natural basis, it also scales up the coordinates with respect to a different basis, b. So secondly, for all x, y in Rn, we have the following, that the coordinates with respect to the sum of the two vectors, x plus y, with respect to an ordered basis beta, equals the coordinates of x with respect to beta plus y with respect to beta. A proof. Well, proof of the first one. Suppose that a vector x expressed in coordinates with respect to the basis b is a vector c. So this means that x equals c1 times v1 plus the cn times vn. So then we see that t times x equals tc1 times v1 plus tc2 v2, etc. until tcn vn. We also know that the coordinates with respect to a basis are unique. So here we found the coordinates with respect to the vector t of x, so, which means that the coordinates of tx with respect to the basis beta are tc1 until tcn, which is actually t times c, which is actually equals t times the coordinates of x with respect to beta. So now point B, assume that x is expressed in the basis beta equals a vector coordinate vector c, and that y expressed to the same basis equals a d vector, so that we know that x equals c1 v1 plus etc. cn vn, and y can be expressed using the vector d. The vector y is d1 v1 etc. plus dn vn. So now if we look at the sum of x plus y, can be uniquely written in coordinates c1 plus d1 times v1 etc. until cn plus dn vn. So that it's not hard to see that actually the coordinates of x plus y with respect to the basis beta equals c1 plus d1 etc. until cn plus dn. And we may split these vector in c plus d, which equals the coordinates of x with respect to c beta, and plus the coordinates of y expressed in beta.